warahmatullahi wabarakatuh. Today we are looking at question 3 of the prelim paper of 2022, the chemistry paper. So to begin with, question 3 says, study the following two organic structures and answer the questions that follow. So if you look at the structure A, we see that it's got 1, 2, 3, 4, 5 carbons in the chain, and there's a double bond O at the end. So that will be an aldehyde. If you look at the next one, we've got a double bond O in the middle. And you've got a double bond O in the center, not at the end, then this will be a ketone. Alright, so to answer the questions, let's look at the questions that they are asking us. Compound A and B are functional isomers. Now the question is, define the term functional isomers. We know that isomers, they have the same molecular formula, but have the different functional groups. So to answer that, let's just go to our writing paper. We are busy with question 3. And we're looking at 3.1, and they asked us to define isomers. They have the define functional isomers. Functional isomers. They have the same molecular formula, but they have different functional groups. 3.2. This is 3. Let's just see the question. This is 3.1.1. Write down the IUPAC name of compound B. So compound B is a ketone. 1, 2, 3, 4, 5 carbons, pent, and it's 3 pentan, 3 one. So that will be 3.1.2 pentan, 3 one. So we got 3.1.1, 3.1.2, pentan 3 ketone, pentan 3 on. So that will be 3.1.2 is the answer. Let's go to 3.1.3. The question is, how does the boiling point of A compare to that of pentanol? So what do we know? Boiling point of A is an aldehyde, right? And then compared to pentan 1-ol, compared to an alcohol. So alcohols have hydrogen bonding. So alcohols have a higher boiling point than ketones and aldehydes. So the question is, how does the boiling point of A compare to that of pentanol? So the boiling point of A will be lower than pentanol. So the answer will be, it's just 1 mark, so it will be lower than 3.1.3. So it will be lower than. Okay, 3.1.4, 3.1.4, and the question is, Explain your answer to question 3.1.3 by referring to the intermolecular forces present in each of these compounds. So we can say, so it's lower than, we can say aldehydes have dipole forces. Dipole forces. Whereas alcohols have hydrogen bonding. Alright, so we know that aldehydes have hydrogen forces and alcohols have hydrogen bonding. And we know that hydrogen bonding is a much stronger intermolecular force. Is much stronger. So we can say therefore aldehydes have dipole forces, thus less energy is required to overcome. To overcome the weaker dipole forces. Okay, it will be 3.1.4. 3.1.5. The question is, how will the vapor pressure? So the vapor pressure works that the higher the vapor pressure, the less intermolecular forces because it evaporates quickly. So basically, we can look at the question, how will the vapor pressure of compound B compared to that of pentanol? So which one will evaporate first? 3.1.B, the ketone. The ketone will have a higher vapor pressure, right? So it will be higher than. You must explain your answer. It's 3 marks, so it will be higher than. The vapor pressure of B will be higher than the alcohol. It will be higher than. And if you have to explain that, we can say ketones have weak London forces. No? Ketones have weak forces. Ketones, yeah, can have also dipole. These forces are weaker than hydrogen bonding. that place, that takes place in alcohols. Okay, so we must talk about energy. Energy is required to separate the weak intermolecular forces. Overcome. Okay, so that will be 3.1.5's answer. Then we go on after 3.1.5, we got 3.2. Okay, 3.2 says learners use compound C to E to investigate one factor which influences the boiling points of organic compounds. So look at C, we see the boiling point is -1, D 36.1 degrees Celsius and 69 degrees Celsius. So what's the difference between C, D and E? All of them are single bond, and then basically we see that they are alkanes, but the chain is getting bigger. An increase in chain length increases the boiling point. That's what we can see from the table. So 3.2.1 says define the term boiling point. Okay, 3.2, 3.2.1. 3.2.1. The boiling point is the temperature at which the atmospheric pressure is equal to the atmospheric pressure is equal to the vapor pressure. Don't lose marks by not knowing your definitions. 3.2.2. Write down the independent variable in this graph. So what do you change? The chain length. The chain length got bigger, right? So what did you change? Change the length of the chain length. 3.2.2. is the chain length. 3.2.3. The question is, write down the van der Waals forces that occur between these compounds. So we see that these are all non-polar. So it's non-polar and non-polar. Basically, you have to introduce the dipoles. So the force here will be London forces. (3.2.4) Write down the conclusion that can be drawn about the boiling point of straight carbon chains. We can say the longer the chain length, the higher the boiling point. The longer the chain length, the higher the boiling point. As chain length increases, the boiling point increases, right? 3.2.4. Okay, so that will be the 17 marks. That will be the end of question 3. And that is how we can go about answering that.